Today, we're going to learn about how to use GitHub's new Artifact Attestations feature to produce a signed document, an attestation, binding an artifact that you build on GitHub Actions back to its source code and build instructions. Now, once you've got that, you can verify the artifact from anywhere using the GitHub CLI, or in a Kubernetes context, you can use GitHub's distribution of the SigStore policy controller. Now, these attestations are signed by GitHub and their content cannot be tampered with. Now, why would you want to produce and verify attestations for your artifacts? Well, it's important to know that the thing you're running in production or shipping to your end users is most definitely the thing that you built. Using artifact attestations, you can enforce policies around which repositories or organizations you want to run code from or build with. Ultimately, this gives you the ability to be more discerning and selective about what code you execute or include as dependencies, which brings a fundamentally new security control to software. You ready? Let's dive in. Here, I have a workflow that creates an artifact. In this case, it's a Docker image, but it could be a zip file, a jar, Debian package, literally any kind of file on disk or container image. All I need to do is insert these few lines of YAML invoking the attest-build-provenance action, and the build will then produce an attestation for the artifact based on signed information contained in the Actions OIDC token. Okay, now let's trigger a run of this workflow. As you can see, it creates my Docker image and puts it in a GitHub container registry. Now note that the artifact does not need to be stored on GitHub to actually be verifiable. You could use another registry available to you. The action will then save the attestations in a special data store so that they can be retrieved by the CLI tool when verifying. Okay, now let's see what verifying the artifact looks like. I'm going to use the GitHub CLI tool from GitHub to check the attestation. This tool is shipped with a special trust root that allows it to check signatures from GitHub's root signing authority. This is checking to see if the container image was built on GitHub and was made by a workflow run on the GitHub organization. Okay, cool. It has verified successfully. You can see some basic detail here, including which repo it came from and what workflow in that repo ran. Now, what if we want to find out some more information like which commit actually built it? We can easily dump out a bunch of information in JSON format. Scroll up and you can see a lot of information in the signature stanza, including the source repository, the event triggering the build, and even the commit digest, and other useful information. You can pipe this JSON to a tool like Open Policy Agent, and you can check it against a policy document, or you can extract values with a JQ filter using the -Q flag. You can also download them for offline verification without a network connection back to github.com. Now, what if we want to give Kubernetes cluster administrators the power to ensure that the only things that they've built are actually being ran in their clusters? For that, we use the GitHub distribution of the SigStore policy controller. The policy controller is a Kubernetes validating webhook that uses a new custom resource definition called a cluster image policy. This will define which container images are allowed in by the admission controller and which aren't. Now let's start by looking at the Helm chart you use to install the controller. You install the policy controller with the Helm chart. This is the source code, but the built chart lives as an OCI bundle in our GitHub container registry. Here we can see that the chart will install a single container image. Let's make sure that it is attested first. I can use the GitHub CLI to ensure that the container image the Helm chart is going to install is exactly what I expect. Okay, looks like it was created by the repo we expect, by GitHub in the GitHub organization. So far, so good. Now let's do the same thing with the Helm chart. Here's where the Helm chart gets published. This is the official way to install this controller. Now it's important to remember that the controller itself is a piece of upstream kit from the SigStore project, which GitHub helps to maintain and oversee. GitHub pulls the upstream and uses it to build our distribution, which we attest. The Helm chart is likewise a version of the upstream, simply customized slightly for GitHub. Let's copy this URL and use it to verify the Helm chart with the GitHub CLI. Okay, so the main thing to be aware of when configuring these resources is the cluster image policy. This defines what you'll accept into the cluster. And once again, we're just dealing with that attestation data in JSON format exactly as you get it on the CLI. We want to make sure that everything we launch in the namespace foobar is signed by our organization. In this case, my organization is GitHub, but you'd use the name of your own GitHub organization. Now we can see the policy controller itself launching in the cluster, and we can confirm that the cluster image policy has exactly what we expect. It will only show the images signed by the GitHub organization. In a real-world scenario, you would change that to point to your own organization, as we showed in the previous step. As you can see, this is really powerful right out of the box. We've heard from countless organizations that the main thing they want to do is simply verify that container images were signed by their build processes. This gives you exactly that. If you want to get more in depth, the documentation on GitHub will explain how to write more in-depth cluster image policies. Thank you all for joining today to learn about GitHub's new Artifact Attestations. We'll put links for all the documentations below. So good luck and happy coding.